Hi, I'm Bob. We have arrived at the section of returns to scale in Chapter 6 about firms and production. When a firm doubles all its inputs, its output could more than double or less than double. We say the firm has increasing returns to scale, constant returns to scale, or decreasing returns to scale. Let's solve the exercises for this section. Here is exercise 5.1. To speed relief to isolated South Asian communities that were devastated by the December 2004 tsunami, the U.S. Navy doubled the number of helicopters from 45 to 90 soon after the first ship arrived. Navy Admiral Thomas Fargo, head of the U.S. Pacific Command, was asked if doubling the number of helicopters would produce twice as much relief. He replied, "Maybe pretty close to twice as much." Identified the inputs and outputs and described the production process. Is the Admiral discussing a production process with nearly constant returns to scale, or is he referring to another property of the production process? The output of the production process is disaster relief. The inputs are the helicopters and the helpers. Doubling the helicopters probably doubles the helpers. So both inputs are doubled. The Admiral means if both inputs are doubled, the tsunami relief nearly doubles. The production process exhibits nearly constant returns to scale. Let's find answers to exercise 5.2. Show in a diagram that a production function can have diminishing marginal returns to a factor and constant returns to scale. The diagram shows constant returns to scale. If the firm doubles both its labor and capital inputs from 1 unit to 2 units, the output doubles from 1 to 2. This is the movement from point A to point B. If the firm continues to double both inputs to 4 units, the output also doubles to 4, which is the movement from B to C. The firm exhibits constant returns to scale. The constant returns to scale is a long-run production characteristic when both inputs are variable. When we fixed capital at 1 in the short run, we can find the change in labor and the change in output according to the graph. We can calculate the marginal returns to labor as labor increases. We find that the marginal returns to labor decrease in the short run. Let's find answers to exercise 5.3. Under what conditions do the following production functions exhibit decreasing, constant, or increasing returns to scale? Part A is a linear production function for a positive constant x. When both inputs are increased by x, the output increases by x. So the production function exhibits constant returns to scale. Part B is a Cobb-Douglas production function. For any constant x greater than 1, we can write the output from increasing both L and K by x. It equals x to the power a plus b times FLK. If a plus b is less than 1, then the production function has decreasing returns to scale. If a plus b equals 1, then the production function exhibits constant returns to scale. If the sum is greater than 1, then the production function displays increasing returns to scale. We apply the same method to part C. Labor and capital are both increased by a constant x greater than 1. We find that if A plus B equals 1, then the production function exhibits constant returns to scale. If A plus B is less than 1, then the production function has decreasing returns to scale. If the sum is greater than 1, then the production function displays increasing returns to scale. For part D, we raise labor and capital by the same proportion of x and have the expression On the other hand, we calculate the product of x and q. We have to compare the two terms to determine the returns to scale. If they are equal to each other, then the production function has constant returns to scale. For the functions that are not homogeneous in L and K, it is hard to find their degrees of homogeneity or the degrees of returns to scale. Let's consider exercise 5.4. The researchers estimated the production function for UK supermarkets. What kind of returns to scale do these production functions exhibit? If all inputs are increased by a constant x greater than 1, the output increases by less than x. The production function exhibits decreasing returns to scale. Let's solve exercise 5.5. As asserted in the comment in solve problem 6.5, prove that G is a scale elasticity. Suppose the Cobb-Douglas production function is Q equals A times L to the power A times K to the power B. The original output is Q1. After inputs are increased by x, we have Q2. Q2 divided by Q1 equals x to the power A plus B, where Q2 over Q1 is the relative change in output, and x is the relative change in inputs. From the definition of elasticity, we can prove that G is a scale elasticity. Let's go to exercise 5.6. Is it possible that a firm's production function exhibits increasing returns to scale while exhibiting diminishing marginal productivity of each of its inputs? Yes, we can think of a production function that exhibits increasing returns to scale while having a diminishing marginal product of labor or capital. For example, the production function is FLK equals L to the power 2/3 times K to the power 2/3. Because when both inputs are increased by x, output increases by more than x. the production function exhibits increasing returns to scale in the long run. On the other hand, the marginal product of labor decreases as labor increases. That is, the production function has diminishing marginal returns to labor or diminishing marginal product of labor in the short run when capital is fixed. Similarly, we can find that the marginal product of capital is also diminishing. Let's solve exercise 5.7. A production function is said to be homogeneous of degree g if the following equation holds, where x is a positive constant. For such a production function, show that the marginal product of labor and the marginal product of capital functions are homogeneous of degree g-1. The production function is homogeneous of degree g if the following equation holds. By definition, the marginal product of labor function is as follows. For a constant x, if both the labor and the capital are increased by x, the marginal product of labor increases by x to the power g-1. So, the marginal product of labor function is homogeneous of degree g-1. Similarly, the marginal product of capital is also homogeneous of degree g-1. We can prove that if a function is homogeneous of degree g, its partial derivative is homogeneous of degree g-1. Let's solve exercise 5.8. Show that with a constant returns to scale production function, the marginal rate of technical substitution between labor and capital depends only on the ratio of K to L and not on the scale of production. A production function has constant returns to scale if all inputs are increased by x, then output increases by the same proportion. The production function is said to be homogeneous of degree 1. Its partial derivative, the marginal product of labor function, is homogeneous of degree 1 minus 1 equals 0. The marginal product of capital is also homogeneous of degree 0. The marginal rate of technical substitution is the negative of the ratio of the marginal products. It is homogeneous of degree 0 too. Let's do exercise 5.9. Prove Euler's theorem on homogeneous functions. Given this result, what can you conclude if a production function has constant returns to scale? Express your results in terms of the marginal products of labor and capital. We start from the production function that is homogeneous of degree g. Differentiating the function with respect to x gives the following equation. It holds for all x, so it holds for x equals 1. Substituting 1 into the equation gives Euler's theorem on homogeneous functions. If the production function has constant returns to scale, g equals 1, Euler's theorem becomes the marginal product of labor times labor plus the marginal product of capital times capital equals the total product. Thank you very much for doing the exercises with me today. See you tomorrow. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.